Hi, everybody. So I want to talk to you today not so much about results, but about the pairing of two technologies that for people that are, for biologists that have been interested in animal communication for a long time, like me, is really advancing the way we understand what the communication between these animals is all about. After years of spending time describing behaviors such as milling or traveling or directional, all of a sudden we can see the detail of their interactions from the air while we record them underwater. And this is really, really groundbreaking for cetacean research, and in my case, for beluga research. The first example of this is all these pictures were taken in the high Arctic at the north end of Cunningham Inlet, where I spent 2014 and 2015 conducting a study of beluga communication in the absence of anthropogenic noise. And there were 14 beautiful instances of natural entrapments where the groups of whales would get cut off from the larger aggregations and then reunited after a few hours. And we had access to a small drone for a few of these entrapments. And so we were able to tell with much precision the group composition of these groups. So not only the number of adults, juveniles, and yearlings, but also which groups had calves. And because when whales are entrapped, they produce contact calls a lot more often than when they are just swimming around in the delta. And my study has focused on contact calls since I started trying to understand the communication of these animals in 2002. This was really the perfect opportunity to try and further our understanding of the function of these calls. So what can you understand when you have a visual from the air paired with acoustics? You can look at the proportion of contact calls in relation to, and other call types in relation to the number of young animals in a group, the numbers of calves and yearlings. You can look at the number of contact calls in relation to the number of adults in a group, and that tells you a lot about signature calls, and I will present this incredible data next year, I promise. And you can also look at calls, whether there are calls in groups with newborns that do not exist in groups without newborns, and this is very illuminating as well. Fast forward a year, 2016 was the first season of my study in a population that has now been formally declared endangered by SARA. This is the St. Lawrence beluga population. Calves in the St. Lawrence have been dying at unprecedented numbers in the past few years. The St. Lawrence is a very noisy place. This is just a cross-section of ambient noise from the mouth of the Saguenay, where there is a ferry lane. And we're looking at whether how mother-calf acoustic contact is compromised by noise. And again, pairing our digital hydrophones with visuals from the drone has been invaluable because we can look at the number, the type, and the location of vessels in relation to the whales from the air. We can also really clearly look at group composition and target those groups that have young calves. The younger, the better. And we can also tally the number, all the occurrences of mother-calf separations. And we can ask and attempt to answer, of course, things like, do these whales use contact calls when they are apart? Are these calls masked in noise? Under what levels of noise are these calls masked? Do the groups come closer together when in situations of noise? Do mothers and calves even swim apart in noisy areas? Maybe the mothers don't want to leave the calves, or vice versa, if it's too noisy, because regaining contact might presumably be a little trickier. So this is an example. It's a little quiet, but you can hear some of the calls. You can, so the characteristic of the St. Lawrence is that it's very turbid. I would doubt that these animals can really see each other when they are a couple of meters away from one another. They need to hear each other. You can see a little calf at the head of the group. The animals are immediately orienting towards the little calf. You can hear a few faint contact calls. So this is the kind of thing that we're looking at. The next, I'm just going to let you absorb this and then I'll talk. So this is a group of males. We knew that we had with us a group of 15 males because a few of them had been consistently photo ID'd. Extremely social scene. These males were incredibly tactile with one another before, during, and after this scene. We videoed them for about 20 minutes. They acted very much like baboons in that they would gang up against the deformed one, whose name was Neo. You probably saw one of the whales had a little bit of a scoliosis. They would gang up on him. You would hear aggressive sounds, and then they would come together and rub with each other and engage in this incredible affiliative behavior, much like the fights and reconciliations that bonobos, not baboons, have. At least it was reminiscent of that. And another interesting thing of this scenario is that we knew we didn't have any females around, we didn't have any calves around. It was a dead-end sort of a bay based in Marguerite. So understanding what kinds of calls you have in the absence of mothers and calves is important. And another really, really interesting thing of being able to pair these two technologies and do photo ID at the same time is that when you hear the same, like the trumpet call, you all could recognize it, I'm sure. It was very, very distinct. We heard it again when we had Neo hanging out with a group of females and calves. Now, we can't be, and that was the only call that there was in common. We need many more of these events to start, matching calls to whales, but it's just telling. It's just one of the little things that we can begin to start to find out by being able simply to watch things that we couldn't before. So thank you to a really great research team and many other associations. But most importantly today, I want to thank Aurora and Kila. Without them, this trajectory that I've been on since 2002 would have been impossible. So I'm very, very grateful.
Do we have any questions?
When you say entrapments, what are they entrapped by, ice or?
No, great question. So they would swim up narrow river canals, and the tides are very fluctuating, and so the tide would go down, and they would get entrapped by sandbanks, and literally like in a pool. And then as the tide would go up, they would be able to get out.
Just a really quick question. What happened to the little calf that was out in front of his group, getting farther and farther away?
Oh, they caught up to him. No, a good ending.